Hi guys. Um, you'll find attached to our Google Classroom today our new book on the atmosphere, and it has 5 chapters. We're going to go through them in the next 5, 6 days. We'll do kind of a chapter a day for a little while. I'm up here in Bemidji. I decided I missed my family, and so um, I decided I was just going to go camp in my parents' yard. So here I am, camping in my parents' yard. Anyways, today, our first chapter is on the importance of the atmosphere. Okay, so we're going to go over the reasons why our atmosphere is important, not necessarily what it's made up of or anything, just why we need our atmosphere. And it starts out here with a mom and daughter talking, and she asks, if Earth didn't have an atmosphere, would it always be cold? And the answer to that is yes. It would be cold if the sun was not out, but it would be extremely hot if the sun was out. And we remember that the planet Mercury has really big changes in temperature from day to night, and that's because Mercury doesn't have an atmosphere. So our atmosphere really works to regulate temperature. It says, what is the atmosphere? If we take the word apart, atmo means gas, okay, and then a sphere is like a surrounding blanket of gas. So our atmosphere is a mixture of different gases, and we think of air as oxygen because that's what we breathe, but there's actually many more elements in the air too, not just oxygen. Oxygen just happens to be the element that we need in order to breathe. These couple little equations right here are just the equations for photosynthesis and for respiration. And these two things are opposite reactions, right? Plants take in CO2, water, and solar energy, and they convert it into something that they can use, and then they give off oxygen. And then the opposite of that, this is what we do. We take in that oxygen and CO2 and sugars, and we can convert it into usable energy. This graphic right here shows the other gases that make up our atmosphere, and we're going to talk more about that in chapter 2. But you can see here in this pie graph, it's kind of small, but you can see that the large amount right here, this is nitrogen. Our atmosphere is actually made up of 78% nitrogen. The blue is oxygen, and then there's a little sliver right here, and if we blow up this sliver, the bulk of that little sliver is CO2, and then there's some other gases here, and we'll talk about why these gases in particular are important. Okay, so we need the gases in our atmosphere, all of them combined, in order to undergo photosynthesis and respiration, and those two things make life possible here on Earth. Our atmosphere is also a crucial part of the water cycle. As part of the hydrologic cycle, water spends a lot of time in the atmosphere, mostly as water vapor. You guys have definitely felt water vapor in the air here in Minnesota in the summertime, right? There are times when there's a lot more water vapor in the air than other times. Sometimes we go outside in the summer and it is like sticky wet. And that is because the Earth is receiving a lot of heat at different rates depending upon what latitude you're at. And so when that water vapor is, or when the temperature is really hot, air will actually hold more water vapor. When it's cold, the air is much drier, which is why it's pretty dry here in Minnesota in the winter. There's another gas in our atmosphere that makes life possible, and that gas is ozone. Ozone is made up of three atoms of oxygen. It's O3. We breathe in O2. But that particular layer is up above the layer that we really use a lot. We'll talk about the layers later, but the lower layer of the atmosphere is called the troposphere. The ozone is actually in the layer above that called the stratosphere. And the ozone is like Earth's sunscreen. It works to kind of filter out some of those really bad ultraviolet rays that can harm us and harm our or change our cells in our body. It helps keep temperatures moderate Our atmosphere works like a greenhouse. You guys have heard about the greenhouse effect. Well, if you've ever been into a greenhouse, it's really warm in there, right? Light comes into the glass, and some of that light and heat escape through the glass, but a lot of it is just kind of reflected back down, and that greenhouse holds the heat in. Our atmosphere does the same thing. There are gases in our atmosphere called greenhouse gases that trap heat in inside our little blanket of air, and that makes temperatures livable here on Earth. Without the greenhouse effect, we would not have life as we know it. It would be very, very cold. Us Minnesotans could probably survive for a little while because we are hardy folks and used to cold temperatures, but we certainly would not have the diversity of life that we have without the greenhouse effect. And then lastly, it provides a substance for waves to travel through. We have to have air in order for sound waves to bounce off of them and for us to be able to hear anything. On Mercury and on the moon, where there's no atmosphere, there's no sound. You can yell and scream all you want and you will not make a peep. Okay, now, here at the end of this chapter, we have a video about what would happen if the Earth lost its atmosphere. And there are 5 questions right here. Okay, so you're going to watch this video and you're going to answer these 5 questions on the Google Doc. If we go into, I'll show you, there it is, on classwork, it's not posted, or yeah, it's posted here. You'll find the CODA's Atmosphere iBook Google Doc. That's where you answer your questions. You click on that. It'll make a copy for you. And so this is just like the last time, but I think there was some confusion here. So here's chapter 1, and there's the spaces for the questions. And then also the iBook is also posted right there. So if you open up the iBook, it looks just a little bit different than when I lecture, but you'll see here's what I just went through. And then at the very end, here are those questions. And then this is the link that you would go to in order to find the answer to those. All right, I will be back with a lecture on chapter 2 tomorrow.